This video is about inverse trig functions. This is AP Precalculus topic 3.9. If you appreciate this content, please give it a like. As with all functions, the inverse trig function is the result of switching the input value and the output value, the x and the y. As a result, the output value of an inverse trig function will be an angle measure. You can express the inverse of a trig function in two different ways. Here we have the inverse of the sine function. You can either give it a -1 superscript, or you can put arc in front of it. Either way, this would be read arc sine x. Example 1. Write the statement, the sine of pi over 6 is equal to 1/2 in an equivalent form using arcsine notation. Switching the input value and the output value, we have the arcsine of 1/2 is equal to pi over 6, which can be either written like this or like this. Because trig functions are periodic, the output values repeat. Like these two input values have the same output value. You cannot make an inverse function if the output values repeat. For that reason, we must restrict the domain first to an interval where none of the output values repeat. In order to make the inverse sine function, we need to restrict the domain of sine to the interval from -pi/2 to +pi/2. That way, none of the output values repeat. Notice that if we tried to use the same domain restriction for cosine, it wouldn't work. We would still have output values that repeat. Instead, in order to make the inverse cosine function, we need to restrict the domain of cosine to the interval from 0 to pi. Notice that with this domain restriction, we have no repeating output values. Because the tangent function has these vertical asymptotes at -pi/2 and +pi/2, we will use these values for the domain restrictions. Notice that on the interval from -pi/2 to +pi/2, none of the output values repeat. The domain restrictions from sine, cosine, and tangent become limitations on the range of arcsine, arccosine, and arctangent. I want you to memorize these restricted ranges. For arcsine, the output values are only allowed to be on the right side of the unit circle between -pi/2 and +pi/2. For arccosine, the output values are only allowed to be between 0 and pi. That's in the top half of the unit circle. And for arctangent, it's similar to arcsine. The output values are only allowed to be on the right hand of the unit circle between -pi/2 and +pi/2. Example 2. Evaluate the following expressions. To evaluate arccosine of -2/2, you should be thinking the cosine of what is equal to -2/2, while keeping in mind the range restrictions for arccosine. If you have not yet memorized these 9 trig values, pause the video and memorize this chart right now. We can discover the reference angle by ignoring the negative sign. The cosine of what angle is radical 2/2? We have memorized that the cosine of pi/4 is radical 2/2. So that's the reference angle. Here are two angles with a reference angle of pi/4. The reference angle is the angle between the terminal side and the x-axis. We are only considering angles in quadrants 2 and 3 for now, because we know that cosine of this angle has to be a negative value. And cosine is the x value on the unit circle, and x values are only negative on the left, quadrants 2 and 3. However, now we consider the restrictions on the range for arccosine. Arccosine values are only allowed to be between 0 and pi. That's the top half of the unit circle. So we will actually ignore the angle that is in the third quadrant. So the answer is whatever this angle is. Looking at the reference angle, we will think of pi as 4 pi over 4. That means the angle in the second quadrant, with a reference angle of pi over 4, is pi over 4 less than 4 pi over 4. This angle is 3 pi over 4. So that is the answer. I'm showing a lot of steps here for instructional purposes, but the goal is, when you get comfortable with this, you should be doing all of this in your head. Part B, to evaluate the arc sine of negative radical 3 over 2, you should be thinking the sine of what is equal to negative radical 3 over 2. We begin by identifying the reference angle by ignoring the negative sign. So let's see, the sine of what is radical 3 over 2. We know that the sine of pi over 3 is radical 3 over 2, so that is the reference angle, pi over 3. Sine is the y value on the unit circle, and in this case we want sine to be negative. So that narrows it down to quadrants 3 and 4, where y values, and thus the sine function, are negative. However, the output values for arc sine must fall between negative pi over 2 and positive pi over 2. So that narrows it down to only this angle in the fourth quadrant. But I want you to be very careful here. Normally, we would think of this angle as having been rotated counterclockwise from 0 all the way around to the fourth quadrant. And normally, we would name this angle by saying to ourselves, well, this is pi. And looking at the reference angle, we will think of this as 3 pi over 3. Therefore, we can think of 2 pi as 6 pi over 3. That means with a reference angle of pi over 3, this angle is pi over 3 less than 6 pi over 3. So that would make this 5 pi over 3. But this is not an acceptable answer. The reason why 5 pi over 3 is no good is because the output values of arc sine must fall between negative pi over 2 and positive pi over 2. Positive pi over 2 is the maximum allowable value. So 5 pi over 3 is much bigger than pi over 2, which stops right here. It goes past pi over 2 and all the way around to here. So even though this falls in the correct quadrant, the fourth quadrant, the fact that we had to go past pi over 2 to get there makes 5 pi over 3 too big. So instead of rotating in a counterclockwise direction to arrive at this solution, we must rotate in a clockwise direction. This keeps us between negative pi over 2 and positive pi over 2. Rotating in this direction, this angle is negative pi over 3. When you rotate in the clockwise direction, it's a negative angle. So we went negative pi over 3 radians, and there we are. So that's the answer, negative pi over 3. To evaluate arctangent of radical 3, you think to yourself the tangent of what is equal to radical 3. We have memorized these values, and we know that the tangent of pi over 3 is radical 3. So that is the reference angle. The reference angle is pi over 3. Tangent is positive, so we know that tangent is the slope of the terminal side. The two quadrants where the slope is positive will be quadrants 1 and quadrants 4. However, we must also consider the range restriction on arctangent. We have to stay in the interval between negative pi over 2 and positive pi over 2. That's over here on the right-hand side of the unit circle. So we will not use quadrant 3. We will stick to quadrant 1. And in quadrant 1, the angle with a reference angle of pi over 3 is pi over 3 itself. So the answer is pi over 3. Example 3. The angle theta is in standard position. The terminal ray intersects the unit circle at point P, whose coordinates are x, y. The points Q, R, and S are the result of the terminal ray being reflected over the y-axis, the origin, and the x-axis respectively. For each of the following expressions, determine which labeled point intersects the terminal ray of the given angles. I think it would be helpful to label points Q, R, and S with coordinates just like point P. Using symmetry, if the point P is x, y, we know that the point Q will have the same y value because it's on the same height. So it's going to be something, y. The x value will be the opposite of this, so negative x. Similarly, if we reflect our way down to point S will have the same x value. It has the same horizontal position. So it'll be x, something. It has the opposite y value because it's down instead of up. So this point is x, negative y. Now I'm going to look at point R as the reflection of point Q. R and Q are at the same horizontal position. They are equally far to the left. So they will have the same x value. They are both going to be negative x. However, point R will have the opposite y value because R is down and Q is up. So the R value, the y value of point R will be negative y, the opposite of y. So now we have coordinates for all 4 points. Part A. To determine the arc cosine of x, you should be thinking the cosine of what is x. In other words, which one of these angles passes through a point with an input value of simply x, as opposed to negative x? You are probably noticing that there are 2 such angles. Point P has an input value of x, and point S also has an input value of simply s. So we've narrowed it down to either point P or point S. However, now we consider the range restriction on arc cosine. It's only allowed to exist in the first quadrant and the second quadrant, between 0 and pi. The output value for arc cosine cannot be in the fourth quadrant, so the answer cannot be S, meaning the answer is P. Part B. To determine the arc sine of negative y, you ask yourself the sine of what angle is equal to negative y. Sine is the y value on the unit circle. So ask yourself which one of these angles is at a y value of negative y. Well, that's going to be one of these 2 angles, either R or S. To choose, we will consider the range restrictions for arc sine. The output values of arc cosine are only in quadrants 1 and 4, between negative pi over 2 and positive pi over 2. Since the output value cannot be in the third quadrant, the answer must be point S. Part C. To find the arc cosine of negative x, ask yourself the cosine of what angle is equal to negative x. Cosine is the x value on the unit circle. So, which angle is at an x value of negative x? We see that there are 2 angles at an x value of negative x, and they are Q and R. We will use the restrictions on the range of arc cosine to decide between Q and R. Arc cosine is only allowed in the first quadrant and the second quadrant, between 0 and pi. Arc cosine is not allowed in the third quadrant, so the answer cannot be point R. The answer must be Q. Part D. To determine the arctangent of negative y over x, you ask yourself the tangent of what angle is equal to negative y over x. Notice that y over x is the slope of the terminal side. It's rise over run. So that means for negative y over x, we are talking about an angle that has a negative slope. So looking at these four possibilities, we have a negative slope along this diagonal and a positive slope along this diagonal. So our answers must be either Q or R, because these are the points along the negative slope. However, arctangent is restricted to the interval between negative pi over 2 and positive pi over 2. That's the first quadrant and the fourth quadrant. Since arctangent is not allowed to be in the second quadrant, the answer must be point S. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.